Hey everyone, this is the video for lesson 9.4. It is on the factored form. This is the final form that you're going to see for quadratics. After that, we learn more ways to go from one form to another. But factored form is definitely my favorite. It shows up more than the other forms. Like understanding how to find factored form shows up like so much, all the way through calculus. So either regular honors calculus or AP. Knowing how to factor is just a huge deal. All right, so we've seen two ways to write an equation for a parabola already. So we've seen the general form and we've seen the vertex form. So the vertex form is the one that we started off in chapter 8. But now we're seeing it again in chapter 9. And general form is this one. So general form is kind of useless. I mean, basically the only thing it tells you is A is the stretch factor. Everything else, this equation basically means nothing. Vertex form tells you a lot. It tells you the stretch and it tells you the vertex. It tells you how much it moves left or right, up or down. That's pretty useful. Now, factored form looks like this. It gives you the stretch and it gives you the roots. So where vertex form gives you the vertex, this one gives you where it crosses the x-axis. So both are equally useful. Where general form is like, you're going to see general form a lot and you're going to need to go from general form to these other forms. But if you're asked to know the qualifications or characteristics, I should say, of a parabola in general form, you usually can't because it doesn't give you much information. So in this, R1 and R2 are the roots and A is the stretch or shrink factor. Notice these are all A. If you had a parabola and you had it written in 3 different forms, it's the same parabola, just written in 3 different forms, but the one thing they have in common is the stretch factor. They all should have the same stretch factor if they are the same parabola. All right, so up here I have our first example for graphing something like this. We have x minus 3, x plus 4. So that tells you the roots. Now, you have to remember something from chapter 8. So look here. This is our the graph. If I took this and plugged it into my calculator, I would get something like this. Now, notice x minus 3, that shows up over here at positive 3. X plus 4 shows over here at minus 4. So back to chapter 8, we remember that minus means to the right. So if I have x minus 3, that means I go to the right 3 and put that point there. Plus means to the left, so go to the left 4, put that there, then draw your parabola. Okay, so it's the opposite, but we've seen that so much in chapter 8 that it shouldn't throw you off too much. Alright, so we're going from general to factored. This is what I'm talking about when I say factored form shows up a lot. In my calculus classes, I'd say every section at least has 1 or 2 problems where the students have to factor. And then they get upset because they're like, well, I suck at factoring. So let's not be those kids. So to factor, I want to take this useless general form that tells me nothing and put it into factored form, which tells me at least a couple things. So the first thing you want to do is make a rectangle diagram and fill in the known spaces. So when I say known spaces, I mean these two. We know it has to be x squared, and the only thing that gets me x squared is x and x. And this 6 is 6. Now to get the 5x, these two boxes have to add up to each other, remember? Like every time we have a box, it's these two are by themselves, but these two are like terms, so we combine them. So 5x is going to be this box plus this box. So to determine those two numbers, you have to think, what numbers multiply to 6 and add to 5? So you look at your general equation, okay, your general form. You look at the last number and say it needs to multiply to this number and it needs to add to this number. Okay, so if you have a different general form, say you have 4x plus 3, then you'd say multiplies to 3, adds to 4. Okay, so this one's multiplies to 6, add to 5. So think about it for a second. What two numbers multiply to 6 and add to 5? That would be 2 and 3. So now you place those numbers in the box or on the side of the box and then finish it. So I put the 2 and the 3 here. Notice that I'm done putting pluses. If it's positive, I'm lazy enough that I don't put positives. If it's negative, I do put the negatives, obviously. So then I finish. X times 2 is 2x, 3 times x is 3x. And I check, so I say right here, check. X squared, 2x and 3x is 5x, so that's good, and 6. So I have that, so I'm good. So the factored form are the binomials on the outside. So this is a binomial, x plus 2. Remember, a binomial is two terms, x plus 2. And then they just multiply each other. So I have y equals x plus 2, x plus 3. The stretch factor on the outside is 1 because the stretch factor up here was 1. Remember I said general, vertex, and factored, so long as it's the same parabola, we'll have the same stretch factor. So since this was 1, there's a 1 out here. We don't write it because we're lazy. All right, so now we're going to do all three. So I have this parabola. I want to write it in vertex, factored, and general. Vertex should be no problem for you because we just did a whole chapter on it. So if I have this and I want to write it in vertex form, that should be easy. Factored, also not that hard because we have our roots. General form is the weird one. These two we can do just by looking. This one we have to do some math. So to get vertex, so start the origin, you go to the left 1, down 8. Then you check the stretch factor. Over 1, up a half, so it's shrunk by a factor of a half. It was not flipped, so we don't have to worry about a negative. So we have y equals the shrink factor is 1/2, x plus 1 because it went to the left 1 squared because it's a parabola, minus 8 because it went down 8. Now you could have wrote y plus 8 over here equals 1/2 x plus 1 squared. That's fine. That's what we did in chapter 8. But just know if you're trying to put it into a calculator, you've got to bring the 8 over. Factored form, we know we went to the left 5, so that's plus 5. We know we went to the right 3, so that's minus 3. Stretch factor is the same. So 1/2 x plus 5, x minus 3. Now to do general, you have to box. Up to you if you go from vertex to general or factor to general. I think it's easier to go from factored because I use this box, this right here, and then I times everything by 1/2. So I have x plus 5, x minus 3, x squared, 5x, negative 3x, negative 15. So I have 1/2, and then instead of writing this piece, I write from the box, x squared, these two make 2x minus 15. Distribute that half in, and I get y equals 1/2 x squared plus x minus 7.5. All right, so you have seen so far that the roots are opposite of what you think, because we think like plus means to the left, so that would be like negative 4, minus is to the right, so like 3. But there is like a property, so it's called the zero product property. It basically states that a root will happen when the equation is set equal to 0. So this happens at both roots. So when you have an equation like x minus 3, x plus 4, we know that the roots are at 3 and negative 4, but just to show, you use the zero product property. You set both parentheses equal to 0 and solve. So I take x minus 3, set that equal to 0, and x plus 4, set that equal to 0. So I get x equals 3 and x equals negative 4. So that's obvious. And these problems, you probably don't even need to set them equal to 0. You probably could see them right away. But this next one's a little bit more difficult because in this parenthesis, we have like I keep saying like, we have a number out front. So setting it equal to 0 is imperative. So you have x plus 5 equals 0, so that's x equals negative 5, easy. 2x minus 1 equals 0, that was a little bit harder. You add 1 and you divide by 2, so x is equal to 1/2. So this one right here is the one that everyone messes up on. They immediately think that the answer is just 1 because that's what's over here, but it's not. You have to set it equal to 0 and solve. So that's huge. All right, so here we are. 6, 7, huge. 15 is review. But 6, oh my God, that's like test worthy. Like the problems are so similar. Just a warning. Okay, so make sure you take good notes. Make sure you take your Google form quiz. You mark as done, and have a good night.